hydroxide should you have? Same, right? Because the hydrogen ion coming from the ionization of water. If you know you have that much hydrogen ion, you should have the same amount of hydroxide. Is water acidic, basic, or neutral? Neutral. Wait a minute. What makes the solution acidic? Hydrogen ions. What makes the solution basic? Hydroxide. If they are equal, we say what? Neutral. If I have more hydrogen ions than the hydroxide, we call it acidic. If I have more hydroxide than the hydrogen, I call it basic. All right? Now, if you multiply the hydrogen ions than the hydroxide, what should you get? Are you going to multiply this column? And this value is a constant value. And we call it ep2. It is a constant value. We call it ionization constant for water. It's a constant. Watch this now. If you multiply them, you get a constant value. If the hydrogen ion is 10 to a negative 5, is that more hydrogen ion than the neutral or less? More. 10 to a negative 5 is larger than 10 to a negative 7, right? If the hydrogen ion 10 to a negative 5, together 10 to a negative 14, what is the hydroxide? Thank you. How come? Together 10 to a negative 14. If you know one, you should be able to figure out the other. Let's go back to this. Neutral. You told me 10 to a negative 5 is higher than 10 to a negative 7. You told me it's more acidic. What happened to the hydroxide? Is 10 to a negative 9 larger or smaller than 10 to a negative 7? Smaller. Smaller. So what are we telling you? The higher the hydrogen ion, the what? The lower the hydroxide. Makes sense, right? The more acidic, the less basic. Such that together, 10 to a negative 14. So, if I stand in the middle, this is neutral. I'm in the middle. If you go to one side, becomes more acidic. Go back to the center, that's neutral. If you go to the other side, that becomes basic. Again, I'm in the center here, that's neutral. Acidic if I go that far, basic if I go that far. Have you noticed that if I go basic, am I going far away from acidic? Yes. The more you approach basic, you're getting further away from acidic. The more I'm going into acidic, I'm going further away from basic. In the middle, we call that what? Neutral. All right? Have you heard people say pH? This shampoo is pH balanced. We wonder what this pH means. Don't get scared. pH, negative log hydrogen ion concentration. Yeah, it sounds scary. It will not be scary in a minute. pH, negative log hydrogen ion. You told me when the hydrogen ion tends to a -7, it is neutral. My teacher in the math told me 10 to the power x log 10 to the power x is equal to x. That's what my teacher told me. Did the teacher tell me that? How about log 10 to a -x is equal to what? -x. Good, you have good background. I like that. So 10 to a -7. Log 10 to a -7 is equal to what? -7. But there is negative out here. Negative times negative will give you what? +7. So it goes without saying, if I tell you that hydrogen ion 10 to a -7, you tell me the pH is what? 7. If I tell you the hydrogen ion 10 to a -2, you tell me the pH is what? 2. You can close the door, guys. Thank you. I appreciate that. That's not bad, right? pOH. Same. What is pOH? Negative log the hydroxide. For a neutral solution, we said the hydroxide is equal to what? 10 to a -7. Remember, they're both equal for neutral solution. And again, young people, the pOH was equal to what? 7. So, you're going to find this information on page 2. If you add the pH and pOH, what do you get? 14. I get 14. Watch this. ppW. That's a constant. How interesting. Now, let's play. You can write it on the opposite page if you want. If pH is 2, what is the hydrogen ion? What would you say? Thank you. Can you see that? What is the pOH? That's given on page 2. What should be the pOH? No, pOH. 12. Thank you. What is hydroxide? You're good. So if you just know one, if you know the pH, you can tell me pOH, you can tell me hydrogen ion, you can tell me hydroxide. You can give me a lot of information. The last question is, look at this. Is this higher than 7 or lower, 10 to a -7 or lower than 10 to a -7? Does this mean acidic, basic, or neutral? You're good. Yeah? There is a table. Is this page 3? Yeah, there is a table at the bottom of page 3 relating the hydrogen ion and the hydroxide. 11, -10. What should you have here? -9. Can you see that? -8, -7. Do you have that? If not, fix it, please. Are you okay? What does that table tell us? Watch here. When the hydrogen ion tends to a -1, what should be the hydroxide? -13. Why? Together should be what? -14. So as the hydrogen ion gets smaller, what's happening to the hydroxide? It's getting big. Isn't this what we said a minute ago? As the hydrogen ion gets smaller, the hydroxide gets bigger. What else we learned from this table? Let me add something for you. When the hydrogen ion tends to a -7, we said neutral. When the hydrogen ion tends to a -5, we said what? Acidic or basic? Acidic. How about 10 to a -2? More acidic. How about 10 to a -8? Less acidic. Instead of saying less acidic, you're so right. You said what? Basic. Yeah, I'd rather hear right what we said. How about 10 to a -10? More basic. More basic. So what can we say? Watch this. As the hydrogen ion gets higher, we say more acidic. As hydrogen ion is less, we say more basic. How about the corresponding pH? The same. We say pH 2, pH 5, pH 7, pH 8, pH 10. What am I trying to tell you? The lower the pH, the what? Can you see that? Please make a note of that. The lower the pH, the what? More acidic. People who do not pay attention, I tell them, the pH is 10. They said, oh, that's very high. That's very acidic. pH 10 is what? That's basic. The higher the pH, the more basic. The lower the pH, more acidic. Make a note of that. That would take us to back to page 4. Let's look at page 4. The hydrogen ion is 10 to a -1. pH is 1. Make sure lowercase p, young people. If you put uppercase p, people will not know what you're talking about. If the hydrogen ion 10 to a -2, pH is 2. 10 to a -3, pH is 3. Who's talking, guys? Young people at the back. Watch this. When the pH changes by 1 unit, the hydrogen ion concentration changes by how many units? This is the same as 1/10, 1/100, 1/1000, 1/10,000. Can you see that? When the pH changes by 1 unit, the hydrogen ion concentration changes how many fold? 10-fold. How about if the pH changes 2 units? The hydrogen ion increasing how many fold? 100. So in the lab, people say, teacher, does it really make a difference pH 1 or pH 3? Is 1 and 3 close together? No, it is 100 times more acidic. 100 times more acidic. So that's very easy. 10 to a negative 1, pH 1, 10 to a negative 3, pH 3, I got it. How about, look at the exercise at the bottom of page 4. Look at the exercise. They are talking about HCl. I learned that it is a strong acid. I bet you learned that too. If you put 0.02 moles of HCl, what happened to those molecules? All of them will ionize. I get 1 hydrogen ion, I get 1 chloride ion. No more molecules done, no more. All of them broke into ions. I say broken to make it easy for you. Young people, you're going to say all of them ionized. All the molecules ionized. Who cares about the chloride? I don't care. Who cares about your chloride? I care about the hydrogen ions. How come? It is the hydrogen ions that make the solution acidic or basic. Ready now? I want to find what is the pH. Let's do it. A hydrogen ion concentration, 0.02. How many sig fig? 1 sig fig. Can I say 2 times 10 to a negative 2? Yeah. I'm ready to find the pH. Negative log. Ooh, this whole thing here. My teacher in the math, can you see every once in a while I step out and I remember what my teacher told me. My teacher told me log A times B is equal to log A plus log B. I hope you remember that from your math. That's not chemistry now. That's the math. Log A times B is the same as log A plus log B. Do I have A times B? Yes. So this is equal to negative log 2 plus log 10 to a negative 2. That's A, that's B. Say it again, please. It's okay? All right. That's A, that's B. Negative log 2, negative log 10 to a negative 2. How can I find log 2? Would you kindly get your calculator out? The calculator you're going to use during the exam. Get your calculator out, the one you're going to use in the exam. Go ahead, write down, put 2 and find the log. Or put log first and 2, depends on your calculator. I don't know which one calculator you have. Just, I did not say put negative, did I? I did not.
No.
You either say 2 log or log 2. Find out which one is your calculator. You should come up with 0.3010. Did you get that?
Yes.
So you use the calculator, right? You use it. Okay. Calculator. What's 10 to the negative 2? Everybody should know that. Log 10 to the negative 2 is what? Negative 2. And I have negative out. That gives me what? Positive 2. Watch and watch carefully. How many sig fig do I have? Go back here. 1 sig fig. Does the exponent determine significant figures? No. The exponent tells me where's the decimal. Keep that in your mind, please. So I have 1 sig fig. I still have 1 sig fig. Where does this 2 come from? From the exponent. Are you with me? Does the exponent determine sig fig? No. One sig fig. Make sure you give me 1 sig fig. I really want you to write what I have here because people say, Then they don't take notes, they go home, they come back, say, teacher, tell me again about significant figures. I'm telling you now. Remember, this 2 represents the exponent. Does not determine sig fig. Why? The exponent tells you where is the decimal. Do I still have 1 sig fig here? Yeah. 1 sig fig here? Yeah. 2 and negative 0.3. What do you get? 1.7? Watch this. This is 1 sig fig. And people go, teacher, I see 2 digits here. How could we say 1? Watch this. Where does this whole number come from? From the exponent. This does not contribute to sig fig. I'm going to say it again and very slowly. The 2 represents the exponent. Does not determine significant figures. This decimal value here comes from this number, which is 1 sig fig. So when we subtract, you see you have 2 digits. But this one comes from what? The remainder of the whole number here. So only the decimal part contributes to sig fig. So if I ask you how many sig fig, you should tell me 1. Why? The whole number is the remainder of that 2 that comes from the exponent. We're going to do another one in a second. Before we go to another one, let me tell you, you really do not have to break it into A and B. Go ahead right away. Go ahead. I do not know really your calculator, but you can go like this. Negative log, open brackets, 2 times 10 to the negative 2. See what you get. You're supposed to get 1.7. Try. You do not have to break it into A and B. You can go ahead and put negative log 2 times 10 to the negative 2 and see what you get. You should get 1.7. Write yourself a note to practice at home. How to go from hydrogen ion to pH. You really do not have to break it into A and B. You do not. Let's take another one.